shortened and condensed explanation of solution chemistry. So we're going to still use the idea of moles, but we're going to talk about how to make solutions. There's a lot of real life applications with this. You guys deal with and probably make solutions all the time. This is a really crucial part in chemistry that we use. So there's just a little bit of terminology that I'm going to go over. We'll then walk through the different calculations, and then we'll talk about an application as well. So I'm going to shorten this in 3 separate videos. The first video, what we're going to talk about is solution formation and just solubility in general. The next video, we will look at concentration specifically. So this is the math portion. This is where you'll need a calculator. And then we'll talk about colligative properties as well. So for this video with solution formation, and again, these notes will be in Schoology as well, but solutions are just homogeneous mixtures. So if you guys remember from the very beginning of the school year, we talked about homogeneous versus heterogeneous mixtures. So these are where you can not see the different components. It can be a mixture of a solid, liquid, or gas. And the 2 terms that you should know are solute versus solvent. So anytime that we mix something together, the substance that is getting dissolved or that is being dissolved is what we call the solute. The solvent is what does the dissolving. The universal solvent is water. And if you remember when we talked about this, it's because water is polar. Because of its structure, oxygen is more electronegative. So again, when we looked at that, oxygen pulls a greater density towards electron density towards itself because it has a greater strength. So because it is polar, it does a really good job of mixing with a lot of different polar compounds. So an example with coffee, let's say the solute would be your coffee grounds and the solvent would be your water. You could also say Kool-Aid. The Kool-Aid powder would be your solute and the water would be your solvent. Salt water. Salt, or the sodium chloride, is the solute, the solvent is the water. So anything that you are dissolving is the solute, and then water is the solvent. Polarity is an issue here, so the whole idea that like dissolves like is important. So polar substances are going to dissolve polar, or polar solvents are going to dissolve polar solutes, and so you could also have nonpolar solutes and nonpolar solvents mixing. So again, this is why oil and water don't mix. So when we have solution formation, we can either have substances that form a solution, we call those soluble, or we can have substances that do not form a solution, which we term insoluble. So in terms of solubility, and again, if we were in school, we would be going more in depth with this. We're not going to focus as much time, but it's really just how much of a solute you can fit in a solution. There are 3 types of solutions that we can have depending on where we're at in terms of solubility. Solubilities can actually be measured and we can have graphical data that shows us this, but it's really just how many grams can you fit in 100 grams of solvent. This is temperature dependent, and we'll see that here on the next slide. If something is saturated, that just means that it has the maximum amount of solute at a specific temperature. So the best way that I have to explain it is if you think about a classroom. If you have a classroom that has a total of 10 desks and you have 10 students, that means we have a saturated classroom because all 10 seats are taken. If it contains less solute than a saturated solution, that means it's unsaturated. That means you could actually fit more in there. So with the classroom example, if you have only 5 students in the class, but you have 10 seats, you could technically fit 5 more people. So with solutions, there's a point where you can then keep dissolving. And then a supersaturated solution is one where you actually cool it down, where it's actually overfull. So this would be like a standing room only situation, or if you had over 10 students, then that means you have too many and it's overly saturated. So if you think about this in terms of making a drink like a coffee, if you have the perfect ratio of coffee grounds to water, that would be a saturated solution. If you then want to add sugar to your coffee, there's only so much sugar that you can add before it just starts kind of sitting at the bottom, if you've ever had that. Same thing with iced tea. If you've ever had sweet tea, that's actually a super saturated solution. Or if you've ever made hummingbird food, you actually have to heat it up to dissolve the sugar, and then if you cool it down, then that is why it tastes overly sweet. So when we look at solubility versus temperature, these are all just the different kinds of substances that we have. If you notice, like sodium chloride, it has a relatively stable solubility. So no matter what temperature we have, we can generally dissolve around 38-ish grams per 100 grams of water. And so that's pretty straightforward. But if we look at something like potassium nitrate, as I increase temperature, I greatly increase the amount of potassium nitrate that I could dissolve in solution. So most solids, if we look here at this chart, the solubility of solids increases as we increase temperature, but the solubility of gases decrease. And if we think about the Y here, as we increase with solids, as we increase the temperature, we are increasing the kinetic energy of the molecules. So you're basically allowing more room for those molecules to fit. But with gases, if you're increasing the temperature, so if we think of this solution here, and let's say I have a whole bunch of gas particles, if I increase the temperature of those gas particles, they're going to move around a lot quicker. And they're going to actually want to escape the solution. And so there's going to be less of those gas particles left after I increase the temperature. Best example of this would be pop. If you've ever had a 2-liter pop or a can of pop and you have it accidentally sitting out in a car for a long period of time, or if you just don't put it back in the fridge, it seems to go flat. The reason is because those gas particles eventually will escape the solution. Okay, so that's just some general terminology, knowing solubility. Again, if we were in school, we would be doing labs with these. We'll be having an activity that we'll be doing later with the calculations. But the next video, if you keep watching, will be on molarity.